Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have a square minus b square equals to 69, and we solve this problem for all the values of a and b. So here you remember one thing is that our a and b must be an positive integer. It means that we solve this problem for only positive integer values of a and b. And now we move towards the solution of this problem. The very first step we are going to do is first you see that a square minus b square with a very famous algebraic formula, and this is equals to a minus b times of a plus b, and this is equals to 69. And now you see here in the left hand side we have these are the two factors are multiplied by each other, but in the right hand side we have only one factor, that is 69. So we need to find any two positive integers whose product becomes 69. So first we find the possibilities of numbers whose product becomes 69. So these are 1 times of 69 is equals to 69, and 3 times of 23 is also becomes here 69. So we have these are the two possibilities whose product becomes 69. And now we make the relation between these two values, and you see that our a minus b is always less than or equals to a plus b. So here we choose we just divide this equation into the two cases by comparing both of these two values with both of these two numbers. Okay, so here first we write our case number one. So in the first case we compare the lesser term with lesser term and greater term with greater term, because you see that 1 is less than 69 and 3 is also less than 23. So we compare the less term with less and greater term with greater, and we get a minus b is equals to 1 and a plus b is equals to 69. So this is our first case, and here we write the second case, and now we compare a minus b and a plus b with 3 and 23, and we get a minus b is equals to 3 and a plus b is equals to 23. So here we call this is our equation number 1, and this is our equation number 2, this is equation number 3, and this is our equation number 4. So first we solve equation number 1 and equation number 2, and we get the values of a and b. So now we first sum up equation number 1 and equation number 2, and we get a plus a becomes 2a. This minus b and plus b are gone, and we get 1 plus 69 becomes here 70. And now we divide both of the sides by 2 in order to get the values of a. So this 2 and 2 are gone. This is 2 times 3 becomes 6, and 2 5s are 10. So here we easily get the value of a is equals to 35. And now we put this value of a into the equation number 1, and we get the value of b. So equation number 1 is implies that a minus b equals to 1, and this will becomes 35 minus b equals to 1, and we get 35 minus 1 equals to b, and 34 equals to b. So we get the value of b is equals to 34. So we get the first order pair of solution is ab equals to 35 and 34. And now in the same pattern we solve our case number 2. So in the second case we again do the same process, and here we sum up equation number 3 and equation number 4. So when we add these two equations, we get a plus a becomes 2a, and 3 plus 23 becomes 26. And now we again divide both of the sides by 2, and we get this 2 and 2 are gone, and we have a is equals to, this is 2 1s are 2, and 2 3s are 6. So we get the value of a is equals to 13. And now for corresponding value of a we get the value of b, and we copy down equation number 3 here. It is a minus b is equals to 3, and we put this value of a here, and we get 13 minus b is equals to 3, and we easily get 13 minus 3 is equals to b. So 13 minus 3 becomes 10 equals to b. So the second order pair of solution which we get here is AB equals to 13 and 10. So we have these are the two roots, and now in the next step we need to verify that is these roots be the solution or is these roots be the extraneous root. So we copy down given question statement here. It is a square minus b square equals to 69, and in this side we verify this pair of solution, and here we verify this pair of solution. So first we substitute both of these two values of a and b here, and we get 35 square minus 34 square equals to 69 or not. So here we see that 35 square is equals to 1225, and 34 square becomes 1156 is equals to 69. So we subtract these two values and we easily get 69 equals to 69. Both of the sides are equal, and now we verify this value and we get here 13 square minus 10 square equals to 69, and 13 square becomes 169 minus this 10 square becomes 100 is equals to 69. So you clearly see that 69 is equals to 69. So both of the above roots satisfied our given question statement, and finally we have the solution set of the given question is the first order pair of solution is 35 and 34. The second order pair of solution is 13 and 10. So this is our final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.